Okay, for this video we have yet another K7000 on the bench here. I kind of skipped ahead in the troubleshooting process because I already have videos on what was wrong with this for the most part, and I'll get to that in a minute. But basically this was the chassis out of our NBA Jam machine up at the arcade. I got a message saying that the monitor had died, and but you could still hear the game running, the marquee was on, all that. So I went up there and checked it out, and sure enough the fuse was blown, the chassis was dead. And I brought it home to check it out, and it was very easy to spot what had happened, very common. The Flyback decided to arc a giant hole in the side of it. Yep, that's a goner. I could have patched that, and this probably could have lived a little bit longer, but the voltage would have just found another way out somewhere else. So the Flyback decided to open up and arc itself to the frame, which there's a little bit of oxidation on the frame where it was obviously arcing for quite a while. And it took out the HOT, and it took out the voltage regulator. So I replaced the voltage regulator, replaced the HOT, checked everything else in the power circuit, put a new Flyback in, and it fired right up. But I got vertical collapse. So, yep. So I figured this will be a good example of what to test and how to repair a K7000 with vertical collapse. So let's get it back off the tube and do some testing, and we'll see what we can find. So here's the chassis on the bench. Let's do some testing. There's a couple of resistors we need to test before we automatically assume the vertical IC is bad, because the vertical IC is very robust. It takes a lot for it to get taken out. Of course, having the Flyback arc all of its voltage straight to the frame and through the ground circuit could very well do that. But in my experience, the vertical IC is very robust. So there's a couple of resistors over here next to the Flyback. And you can actually see where it was arcing to the frame. If I can get in here and show you. This whole oxidized area right there is right where obviously it was arcing to. This whole circle, you can see all of the dirt is gone, and it's pitted and oxidized. So it was arcing to the frame for quite a while. And yeah, it caused some damage. So, but there are a couple of resistors that are responsible, just like most other chassis, for your vertical circuit that provide the voltage to the vertical IC. So if either one of these two resistors are bad, you're gonna have vertical collapse, and you don't obviously want to automatically assume and go right to the vertical IC as being the problem. So in this instance, we're going to check these two resistors first to see. It's R91, R91 is further back, but R92 is this guy. There's R92 right here, and R91 is back here, and it's already missing. My other donor chassis here actually has it. So this guy right here. This is R91 right there, and R92 goes right here, which was this guy right there. So if either one of these two are bad, R91 or R92, you'll have vertical collapse, either one of them. So they both are a 1 ohm resistor or 1.2 ohm resistor. So if we test R92, sorry, we'll do 92 first. Okay. So R92 was this guy here, and we got 1.2 ohms, give or take. Around 1.3. So let's test this one. If we look here, the resistor is actually between this pad and this pad is between the hole here for the feet for the Flyback. So we can go from this pad to this pad on the bottom side. We can actually test it and see. There we go, 1.4. So let's test this one. Is this one good too? Excuse how dirty this is with flux. I haven't had a chance to clean it yet from the previous repair. As a matter of fact, it was rebuilt 28 November of 15 and was lazy, and this didn't get cleaned up. So, but if we test let's see what we have here. 1.3. So it's not R92. Now R91 is up here between the capacitor and the frame. It's this guy right there, and the leads should be right on either side of the ground trace here. There we go, 1.2. So R91 and R92 should both read 1.2 ohms. There's 1.1, and then this was, oh, it's gone. Sorry, it's the other one. So R92 is 1.2, and then R91 is 1.2. So again, if we go to the two pads on either side of the ground trace here and test R91, look at that. R91 is most likely open. I think we found our problem. Well, I'm assuming so. Obviously that's a problem. The best way to test your voltage or your vertical IC is we can go to diode mode, so I can zoom in here, and if anything is grounded, you'll hear it. If any of these pins are grounded, you'll hear the ground. So if we actually go to a ground here, which is here, and if we were to touch, this ground or this ground, there's ground. So this should be ground here, and we're hoping for none of the other pins to read to ground. So if you can see the meter, see now it doesn't ring. The meter has to, there's a capacitor in circuit for this. That's why it beeps for a little bit and then stops beeping, because the capacitor has to discharge from me discharging it through the trace to ground. So pin 1 is our ground, pin 2, nothing, 3, nothing, 4, nothing, 5, nothing, 6, nothing, 7, nothing. So our vertical IC is not shorted. That's the easiest way to test that. It could still be bad, but it's not shorted, so that's the important thing. So I think fairly confidently I can state that R91 is the culprit. And now that I look at it in the light, it's rather charred and burned. So let's get R91 out of circuit. It's going to be tough trying to replace it. Hey, I'm popular. I got a message. My one message a day. Okay, so let's get R91 out of circuit here, and we'll test it again. And fortunately, we have a donor that we can use. Okay, so it's going to be this guy. Oh, come on. I don't want to turn my desoldering gun or desoldering station back on just to do these two pads. Boy, let's go the alternate method here and add some new solder. Now watch it go right up. Alright, there's that one. And there's that one. Alright. Can I snake in here and grab that out of circuit? I can. There you go. Now take a look at it. It is toasty. There it is. Yep. So we'll set this aside and let's test it. Do I have a way to do this here? Let's just use this. And we'll zoom out. What does it read? Open. Completely open. If I touch this, there's my, well, actually, I'm sorry. Touch here. So our leads are good. If we go back to the, oh, it's not open, but it's reading 900K, 845K. So, toast. Looks like altogether the Flyback took out the HOT, the voltage regulator, and R91. So that's not uncommon. Let's steal R91 from this chassis. And it should be this one. this one. Yeah, you gotta do this from time to time. There we go. Got it. So we yank this out of here. Perfect. Okie dokie. I seriously doubt that I'm going to be able to get this in circuit the way that this is. I'll try my best here. I don't want to put it on the bottom, but in order to get in there to get this, I'd have to take the HOT back out, take this back off. It's just a nightmare to try and get in there to replace this. So I may end up putting it on the back just temporarily until we can just at least test it, and I'll do it properly later for the purposes of the video. Or you know what? I'll tell you what. I don't like to cut away to minimize, you know, oh, you swapped out this and did that. No, I want to leave the camera running, but I may have to cut away until I actually get this installed, because I got this giant capacitor in my way, and I don't know if I'll be able to snake. Oh, I got one leg in there. Can I get the other leg in? Am I lucky enough to be able to do that? Oh my Lord, amazing. I never get that lucky. You've got to be kidding me. All right. Well, yeah, went right in. Imagine that. Got both feet through. I can't, that never happens. So, let's get this. Don't fall, don't fall, don't fall, don't fall. Let's see if I can push on it a bit to get a bit more. There we go. That's good. All right. So let's do this side now. Okay. Now it may read higher than 1.2 because it's hot. But let's just make sure it reads good now. So if we go on the two pads on either side of the ground trace here, 2.9. Yeah, as expected because it's hot. But I think that will fix the problem. So I'm going to actually get this cleaned up, and then we'll get it tested, and we'll see if that fixes it. So give me 1 second here. Okay, got it all cleaned up. Good enough for government work, and now it's ready to go on the tube and test, and we'll see if replacing R91 fixed the problem. Fingers crossed. One moment. Okay, all hooked up, ready to go. Let's see what we get this time. Oh, something's not right because it didn't power up this time. That's very odd. I didn't do anything. The isolation transformer started humming rather loudly. You saw it was working just fine. All I did was replace R91. Very interesting, very interesting. Let's try again. Let's take the video source out. And, we got anode, neck, yoke is hooked up. We got our DAG ground connected. That should be it. Nothing else got changed. Let's try again. Nope. Well, that's very odd. Okay. Well, hang on. Let's see if I can figure it out. Well, I found the problem. Let me take you on the journey to show you what's going on. Alright, so if we look at this donor chassis here, R91 sits inside here. R91 sits right in here, in this area right there next to this capacitor. Now it's connected to the leg of D13 here. Let's see, this is the cathode. The anode is the side without the stripe, and the cathode is the side with the stripe. I could have that backwards, but I'm fairly certain that's accurate. But regardless, the side of the diode with the stripe shares a trace with the leg of R91. You can see right there. These two share a trace. If we flip it over, R91 is here, and it goes right to D13. So if we test D13 on this chassis, the negative is going to be here, and the positive is going to be here. We should get a diode. There you go. Now if we go to this chassis, and we do the same thing, negative lead here, positive lead here, shorted. So D13 is shorted. Now that's not unexpected now that I think about it. Since R91 opened up, which is these two pads here, it took out D13, or D13 opened or shorted and took out R91. One of these two killed the other one, or both. So we're gonna have to change D13, and apparently the chassis will operate with an open R91 and a shorted D13, but it will not operate with a working R91 and a shorted D13. So we're going to have to remove D13, replace it, and then I'll bet it'll work. So here we go. Let's take this and set this aside. And for the sake of making a shorter video, I'm going to pluck D13 out of here, and we'll put it in the other chassis, and when I come back we'll have that done, and then we'll test it. So hang on one moment. Alright, so I have the shorted D13 out of the chassis and the good D13 out of the donor chassis and into this chassis. So we'll do our double checking here. We got negative on the side with the stripe, positive on this side, and if we check it here, 100% shorted. If we go to ohms, 0.2. So this diode is kaput. Now, you won't believe how difficult it was to try and get this in here. I was able to finagle it in there with my tweezers after much bending of legs and trying to get it in there. I got it in there successfully. Got it soldered in. And let's test it. So we'll go back to here and we'll test our R91 again, which should be 1.2 ohms either side of the ground trace. There, 1.5 good enough. Now we'll go to our diode, and there you go. Bada bing. And D14 is the opposite direction. D14 is good as well. So now I think we're going to be good. So now let's we can say that the arcing flyback took out D13, R91, HOT, and voltage regulator. So let's try again. We'll get it on the tube and turn it on, see what we get. Okay, one more time. Here we go. All hooked up, ready. Let's see what happens this time. Yes! Power. Do we have collapse? Well, we no longer have collapse, but something ain't right there. That's way off. But our contrast and black level is still all the way down. Let's turn down our flyback until we lose our raster lines right about there. And let's try brightness and contrast. Vertical sync. I got no vertical sync control. That's not good. Let's get this on the tripod here. Alright, so I don't have, it's not a connection issue. Oh, it is. I got it. Okay, so I have a bad connection on the chassis for the vertical hold wiring, which I can fix that. Let's do vertical size. H position, vertical position, So I didn't have that problem on the tube that this chassis came with, so I didn't think it was a connection problem. But that's a good example right there of why it's always important to tie those wires off on the corner of the boards to prevent them from breaking. So it must be holding on by a couple of strands. I'll have to fix that. So that'll be off camera. We don't need to worry about that. But let's see if we can make this look a bit better. I was completely unaware that the chassis will operate with a shorted D13 if R91 is open. If R91 is working and D13 is shorted, it will not operate. That's a learning experience for me, and I assume probably for you guys too. But okay, so again, let's try this from scratch. Contrast and brightness down. Screen up until you get raster, back off until they go away. Contrast, brightness. We are way out of focus. That's good there. Not quite. That's not quite good. Let's just go into the menu here. And we'll leave it here. There we go. Let's turn our contrast back down. Well, right about there is as good as I can get it for now. Yeah, I got. Well, see, that's not. The problem is the colors are dark and dim because this was obviously set up for a different tube. So there's not really any reason to kind of try and go through all of this rigmarole of adjusting everything, because that's good enough right there. I was going to say because this isn't staying on this tube, but that's pretty good right there. So yeah, there you go, guys. Vertical collapse repaired by R91 and D13, and an arcing or shorted flyback, or whatever you want to call it. Took out the HOT and the voltage regulator. Well, in D13 and R91. So we had those 4 bad components all taken out by the shorting or arcing flyback. So if you want to consider that not as a factor, let's just say you have vertical collapse, you have R91, R92, D13, D14, or a faulty vertical IC. So hope this helped you out. If you have questions, make sure you comment, like, share, and subscribe if you want. And I appreciate it, and we'll see you next time.